Assalamualaikum and hi. My name is Lailatul Fikri bin Razali. My metric number is CN200-241. Okay, today I want to present for my final year project presentation 1, which is optimization of permutation for short scheduling problem using first sequence artificial B colony Fsabc algorithm. Okay, thank you to my supervisor, Dr. Aziz Binawi, for guiding me to doing this project. For the introduction, scheduling is the act of assigning resources to complete a specific set of tasks within a specific time frame. In a business organization, scheduling includes a strategy, uh, which is for clarity, and task priority must be complete in a specific order. Okay, product scheduling is crucial for organization competitiveness in consumer marketplace, which is it's a link to the optimization of performance measurement, where all processes are functioning smoothly to reach the objective of satisfying customer satisfaction, such as resource efficiency. Okay, for flowchart scheduling, is a well-known problem in operational research that has been widely researched. Many approach to solving this problem, which three approaches. First one is heuristic, second one is a meta heuristic, and third is precise algorithm. Okay, for flowchart scheduling, we use ABC optimization, which is a meta heuristic algorithm for finding optimal solution iteratively. Okay, for the background of the study, okay, R. Liu in 2023 says that product scheduling improve customer satisfaction, efficiencies, and production cost saving. Gunantra and Nuelda Putra in 2019 and Wen in 2023 said that exact algorithm and meta heuristic tackle flowchart scheduling issues but are slow for big situations. Shen in 2021, Yanesi and Yagamahan in 2014 said that flowchart scheduling research explore heuristic, meta heuristic, and precise algorithm. And the last one is Karabuga in 2005 found that ABC optimization is a meta-heuristic algorithm based on honeybee foraging behavior utilizing multi-agent system. Okay, for this project problem statement, for this project, for the problem statement of this project is the original ABC algorithm is known to be a slow converge, and this shortcoming caused the process of obtaining good quality max span values to be sluggish. The algorithm will continue to discover a better solution as the iteration advances. When convergence occurs, the potential solution begin to migrate closer to the desired point. According to the research, the convergence speed in ABC is sluggish and the algorithm will take some time to reach the required result. Although the exploratory efforts are claimed to be balanced, the convergence speed can still be improved. Okay, the main of this study is to create a new enhanced ABC algorithm that includes extra convergence mechanism to help it converge more successfully. The entire process is referred to be a newly developed first sequence artificial B colony, which is Fsabc, heuristic design exclusively for solving permutation flowchart scheduling problem. Okay, the study is to focus on improving the original ABC algorithm by directing the first solution to areas within high quality solution for optimizing Pfsp, which is permutation flowchart scheduling problem. The enhancement will help the ABC algorithm provide a good result in less time. Okay, the objective of this study is first is to develop the coding for permutation flowchart scheduling problems, and then to develop the coding of the first sequence artificial bee colony algorithm for optimizing Pfsp. And then the last one is to assess the performance of Fsabc algorithm against the current ABC algorithm in the context of optimizing Pfsp. Okay, the scope of this study is the study focus on permutation flowchart scheduling problem, which is Pfsp. Okay, the Pfsp case studies include 10 jobs, 3 machine, 15 jobs, 3 machine, and 20 jobs, 3 machines. This study coding will be done in Microsoft Visual Basic for Excel, which is VBA. The significance of this study is the study will approach a new first sequence artificial bee colony algorithm to outperform the old ABC algorithm. And the effectiveness of Fsabc for Pfsp is in provided a good result in less time. The literature review for this study is to see the past research about ABC, which can we see at this table. In 2013, there are both modification of ABC, where the application is for job shop scheduling (JSP), and second one is to order acceptance into machine flow shop. Both researcher for JSP is Jane in 2013, and for the order acceptance into machine flow shop is Wang. In 2018, Meng create a hybrid ABC for flexible job shop scheduling problem with overlapping in operation. And in 2020, Li improved artificial bee colony IABC is to disturb heterogeneous hybrid flowchart scheduling problem with sequence dependent setup times. And then the next year, which is 2021, Li also create discrete artificial bee colony algorithm, which is DABC. The application is to disturb heterogeneous no weight flowchart scheduling problem. Okay, the same person also in 2022 create adaptive ABC, which is AABC, is for parallel machine scheduling. In methodology, firstly we will build scheduling solution formation using normal ABC method. As we can see, there are pseudocode illustrated for build the scheduling solution formula, which is firstly is procedure ABC methodistic. Second one will be find an initial solution. While in the criterion, we will update feasible solution, which is EB, employed Bs, and then we will select feasible solution, which is onlooker Bs, and then we will update feasible solution, which is onlooker B also. And the last one is avoid suboptimal solution, which is SP, scout B. And after we done doing the criterion, we will end while, and then we will end the procedure. In the phase of the beast, there are 3 phases, which is first one is employed B, EB phase. The system will instruct the employed bees, EB, to search for food sources in the surrounding region in their memory, and the information will be shared to the onlooker bees, which is OB. The ABC algorithm either to alter the work sequence of the flowchart using swap and insert method. As you can see in the picture, the left picture is a swap method. There are 5 jobs, J1, J2, J3, J4, and J5. The J2 and the J4 will swap each other and we will get the J1, J4, J3, J2, and J5. Okay, in the right pictures, you can see that insert method have been applied to the J1, J2, J3, J4, and J5. Okay, J2 we will insert in between the J4 and the J5. So the result will be J1, J3, J4, J2, and J5. Okay, next, onlooker B phase. Onlooker B phase will choose the food source depending on the quality of the answer. The input for OB in the selection process is the finest value of each solution and the mapping computation. And the last one is scout B phase. The function of scout B phase is looking for other food sources for next food source. Next, we will develop ABC algorithm in Excel VBA program. Okay, for AB codes, as we can see, OB codes. And the last one is to utilize the code for memorize the best solution. PS, for the onlooker B variation of location, we will use non-greedy, which is 1 plus 1 plus 1. Next, we will develop the first sequence artificial build colony heuristic. In this development, we will use first job sequence technique, which were the number in the red boxes is fixed while the rest are chosen at random. As we can see at the picture, the first box is the first job sequence, and the 5 job below will be random. Okay, the procedure for Fsabc will be illustrated by the Pfsp code. Okay, first we set the parameters, and second one will generate the initial population. Third one is evaluate the solution in the population. Okay, and fourth is set the cycle equal to 1, and then we repeat the method, and then we generate a new solution for EB input EB using a swap mechanism and evaluate the solution. Next, we will keep the best solution for non-greedy for onlooker B OB, and then generate a new solution for onlooker B OB using the swap mechanism and evaluate the solution. Then we will determine the abandoned food sources and replace using the scout B SB. And next, we will memorize the best solution. Then we apply first job sequence method using the best solution in the previous step, which is memorize the best solution. And then memorize the best solution so far. Okay, next is cycle equal to cycle plus 1. And the last one is until cycle, which is MCN. Okay, next we will perform assessment of Fsabc heuristic against all ABC algorithm. We will compare both algorithm by calculation and generate it into a chart by using Microsoft Excel. This is a sample size calculation. The formula is n equal to zs divide to a x bar the power of 2. Okay, z is a number of a normal standard deviation needed for desired confidence, and the s is a sample size standard deviation. For a is a desired accuracy percentage, and x bar is for sample mean. Okay, for the z value, we will use a confidence level table. As you can see that the table is, we will get the confidence level in the left and the z critical value in the right. Okay, and then we will insert the z value into the formula, and we will calculate it, and we will get 14 times for the sample size. Okay, according to the calculation, the number of samples should be more than 14. So the result will decide to focus on 20 samples. The ABC algorithm we will set as a benchmark for the performance test, and the data scope will obtain from eTalent as follow: 20 job 5 machine, 20 job 10 machine, 50 job 5 machine, 50 job 10 machine, 100 job 5 machine, and last one is 100 job 10 machines. As you can see the table below, this is a number of EB and OB for each flow shop configuration, which is a colony size. After doing the calculation, we will generate chart in Microsoft Excel based on factors and response that been obtained. There are two, which is factor and response. As you can see, factor we have three: algorithm, iteration, and dataset. And for the response, we have two, which is max span value and percentage of improvement. Okay, for the flowchart of the whole ABC algorithm, first, it will develop a population of n scope base, and then assess the population fitness, decide MSAT for neighborhood search, then determine the size of the neighborhood. Okay, next, the recruit base for the selected location, then choose a representative B from each batch, and then assign remaining Bs to random search. Then the new population of scout bees created, and it will repeat step by step of this method until it complete a cycle. Okay, for the flowchart of this study, first we'll detail a literature review on ABC algorithm for scheduling purpose, and then we will build scheduling solution formulation for the manufacturing scheduling problem using a normal ABC method, and then we will verify Excel VBA code. If the code not verified, we will repeat the step which we we will build the scheduling solution. And if the code verified, we will go to the next step, which is observe and investigate the manufacturing scheduling problem using a normal ABC method. Okay, then we will observe and investigate initial population of ABC algorithm, and then we will develop appropriate algorithm using the first job sequence arrangement, and then validation of algorithm performance. Then if the method not validated, we will repeat the step which is to develop appropriate algorithm using the first job sequence arrangement. If the method validate, we will go to the next step, which is documentation and reporting. Okay, for the expected result of this study, uh, the Fsabc will be able to optimize Pfsp, which is permutation flow shop scheduling problem, and its performance will be equivalent to the existing ABC. This permits the Fsabc algorithm to spend less time exploring invisible area of the search space and more time exploring the search space surrounding variable solution. Okay, this is my project Gantt chart. Okay, that's all for me. Thank you for listening to my presentation. Thank you, and have a good day.